Welcome to our channel, where we explore the fascinating world of quantum computing. Today, we're going to introduce you to the basic concepts of quantum computing and why it's important. To begin, let's talk about the fundamental differences between classical and quantum computing. Classical computing uses bits, which can only be in one of two states, 0 or 1. Quantum computing uses qubits, which can be in multiple states at the same time. This allows quantum computers to perform certain tasks much faster than classical computers. Visual aid displays. Comparison of bits versus qubits. Host. But how does quantum computing work? Quantum computers use the principles of superposition and entanglement to perform calculations. Superposition allows qubits to exist in multiple states at the same time, while entanglement links the states of two or more qubits together. Visual aid displays. Superposition and entanglement. Host. The potential applications of quantum computing are vast and include everything from drug discovery to cryptography. Quantum computers could potentially solve complex problems that are currently impossible for classical computers. Visual aid displays. Quantum computer with applications. Host. However, there are still many challenges to overcome before quantum computing becomes a mainstream technology. One major challenge is the issue of quantum decoherence, which causes qubits to lose their quantum properties and become classical bits. Visual aid displays. Quantum decoherence. Host. Another challenge is the need for specialized hardware and software to run quantum algorithms. This is where companies like IBM and Google are leading the way with their quantum computing platforms. Visual aid displays. IBM and Google logos. Host. In conclusion, quantum computing is a fascinating and rapidly developing field with the potential to revolutionize computing as we know it. While there are still many challenges to overcome, we believe that quantum computing will play an increasingly important role in the future of technology. Outro music plays. Quantum computing takes advantage of the principles of quantum mechanics to perform complex computations that classical computers struggle with. One of the key differences between classical and quantum computers is the basic unit of information they use. Classical computers use bits, which can represent either a 0 or a 1, while quantum computers use qubits, which can represent both a 0 and a 1 at the same time, known as superposition. Another important principle in quantum computing is entanglement. Entanglement is a quantum phenomenon in which two or more particles become connected in such a way that the state of one particle is dependent on the state of the other. This property allows quantum computers to perform certain computations much faster than classical computers. One of the most famous algorithms in quantum computing is Shor's algorithm, which can factor large numbers exponentially faster than any known classical algorithm. This has important implications for cryptography and security, as many encryption methods rely on the difficulty of factoring large numbers. However, quantum computing is still in its early stages and faces many challenges, such as the difficulty of controlling and scaling qubits. Nevertheless, many experts believe that quantum computing has the potential to revolutionize fields such as drug discovery, materials science, and cryptography. That's it for this introduction to quantum computing. In future videos, we'll dive deeper into the concepts and applications of this fascinating field. Quantum computing is still a rapidly evolving field, and as more progress is made, we're sure to see some incredible advancements in the near future. In fact, many experts believe that quantum computers will eventually become as common as smartphones are today, with widespread use in fields like finance, cryptography, and materials science. So if you're interested in the future of computing, or just love learning about new technologies, quantum computing is definitely a field worth exploring. There are plenty of resources available online, including videos, tutorials, and even online courses, that can help you get started. And that's it for this introduction to quantum computing. I hope you found it informative and exciting, and I encourage you to continue exploring this fascinating field. In the meantime, be sure to subscribe to our channel for more videos on quantum computing and other cutting-edge technologies. As mentioned earlier, quantum computing is still in its early stages, and its development has been hindered by technical challenges such as noise, error correction, and scalability. However, researchers and companies around the world are actively working on overcoming these challenges to unlock the full potential of quantum computing. In conclusion, quantum computing is a promising field that has the potential to revolutionize various industries, from finance to healthcare to national security. Its ability to perform complex calculations and simulations at an unprecedented speed could lead to breakthroughs in fields like drug discovery, climate modeling, and cryptography. With continued investment and research, we may see quantum computers becoming more prevalent and accessible in the near future. So, how does quantum computing work? In classical computing, bits are used to represent information, with each bit having a value of either 0 or 1. However, in quantum computing, quantum bits, or qubits, are used instead of classical bits. A qubit can be in multiple states simultaneously, which means that quantum computers can perform multiple calculations simultaneously, leading to exponential speedups in certain computations. One of the most famous algorithms used in quantum computing is Shor's algorithm, which can factor large numbers exponentially faster than classical computers. This algorithm is of great importance in cryptography, as it could potentially break many of the encryption techniques currently in use. However, there are still many challenges that need to be overcome before we can see widespread adoption of quantum computing. One of the biggest challenges is the issue of quantum decoherence, where the qubits lose their quantum state and become classical bits. This can happen due to various factors such as environmental noise and imperfect hardware. Despite the challenges, the potential of quantum computing is vast, and researchers and companies around the world are working hard to advance the field. With the development of quantum computers, we could potentially solve problems that are currently beyond the capabilities of classical computers and revolutionize fields such as drug discovery, financial modeling, and more. And that's it for this introduction to quantum computing. In future videos, we'll dive deeper into the various aspects of this exciting field. Thanks for watching and stay tuned for more. If you're interested in studying quantum computing, there are a few things you should avoid doing to make the most out of your learning experience. Here are some things you should not do. Don't underestimate the difficulty of the subject. Quantum computing is a complex field that requires a deep understanding of both computer science and quantum mechanics. It's not something that you can learn overnight, so be prepared to invest a significant amount of time and effort. Don't skip the basics. It's essential to have a solid foundation in math and physics before diving into quantum computing. Make sure you have a good grasp of linear algebra, calculus, and quantum mechanics before trying to tackle more advanced topics. Don't ignore the practical side. While theory is crucial in quantum computing, it's also important to have hands-on experience with programming and quantum hardware. Make sure you're familiar with programming languages like Qiskit and have access to quantum simulators or real quantum computers. Don't be afraid to ask for help. Quantum computing is a rapidly evolving field, and it's easy to get lost in the vast amount of information available. If you're struggling with a concept or need guidance, don't hesitate to seek help from experts or join a community of learners. By avoiding these pitfalls, you can set yourself up for success and make the most of your journey in quantum computing. Thanks for watching this introduction to quantum computing. Don't forget to like and subscribe for more videos on this exciting topic. In the next video, we'll dive deeper into the principles of quantum mechanics and how they relate to quantum computing. See you in the next video.